Okay, so what we're going to do today is go over some review questions that I wrote for chapters 9 and 10 to get us ready for the midterm. And so I just posted these the other day. You may not have noticed them, but these are exactly what we need to get ready for that midterm because they cover what we were doing in chapters 9 and 10. And basically, this is an opportunity to get some more practice with hypothesis testing. Okay. So, of course, in chapter 9, we only focused on one population at a time. We looked at populations, the population mean and the population proportion. So, what I've done here is I've taken the chapter 9 problem set and I've copied the first question. Here it is. Okay, so this one has five questions. The first four are based on the mean, and the last one is the proportion. Okay, so let's take a look at how this works. All right, so hold on. Here we go. So first things first, what exactly do we want to know? Well, the Domino Company, which is a real company, as you know, they produce sugar packets that are supposed to contain 3.5 grams of sugar. Suppose that the FDA is concerned about this. They are worried that maybe the packets are underfilled. If they are, then the company will be fined, all right, because it's false advertising. So, but they don't want to do this unless there's hard proof that the packets are really underfilled, because every packet is slightly different. So they don't want to jump to conclusions, but if they find hard evidence that the packets are too light, then they're going to have to find the company and force them to fill them up more. So, how do we start this out? All right, well, we have, of course, our null hypothesis and our alternative. Now, remember, what we're looking for is hard evidence that the packets are underfilled. So, probably your best bet is to do this. Write that out as your alternative hypothesis first. I think that that will make it less likely that you'll get something backwards. So, oh, hold on one second. I just realized the tablet's not on. Yeah, it's wireless, and sometimes it's on, sometimes it's not. I just have to fool around with it. Oh, technology. All right. Let's see if that's working. Oh, there we go. Okay. So we're looking for hard evidence that the mean is less than 3.5 before we take any steps. And therefore, we're going to run this as a left-held test. Okay, this way we will not conclude that the packets are underfilled without hard evidence of it. Okay. That means that here we have mu greater than or equal to 3.5. And then, of course, we need a level of significance. Now, for this type of test, what is the test statistic? Well, it depends on what kind of data we're given. First, we have a random sample of 70 packets. And the sample mean is 3.4 grams. And the sample standard deviation is 0.2 grams. Now, that's the key to the whole thing right there. They wouldn't be giving us the sample standard deviation if we knew the population standard deviation. So therefore, this tells me to use the t distribution. And that's how we identify the correct test statistic. And of course, mu zero is the hypothesized mean. And of course, you recognize all the rest. X bar is the mean, sample mean, S is the sample standard deviation, and of course, N is the sample size. All right, so we'll plug everything in. All right, and let's see what that gives us. I've got negative 4.18. All right, now remember, from here, we can go in two different directions. We can use the traditional test statistic critical value approach, or we can find the p-value, or we can do both. So you know what? Why don't we do both just to give it practice? So now, of course, this is a left tail test, so we're going to have negative T alpha. The degrees of freedom for these tests is always n minus 1. All right, so now how do we find that in the calculator? Second vars. Number 4 is INVT. Oops. And of course, once you choose INVT, it will need to know two things, area and degrees of freedom. Now, of course, when it says area, it means left tail area. And of course, the degrees of freedom is 69. That's n minus 1. All right, so you should get negative 1.671. That is, of course, our critical value. And any test statistic to the left of that will lead us to reject the null. This is our rejection region. But of course, the test statistic is enormously negative, negative 4.18. That's not even close. That's pretty far off. So that, of course, means reject the null and accept the alternative that sadly enough, the mean is less than 3.5. And you know what that means? They will be fined. Ah, but you can see that we do have the hard evidence. That negative 4.18 is quite a ways out in that left tail. So it's not really even that close. Although it sounds, I mean, 3.4 ounces versus 3 grams rather, versus 3.5 does sound awfully close. But the thing is, what we have to think about is how many standard deviations away are we, not the number of grams. Now, of course, we also could have used the p-value approach. So we're looking for a value that's more extreme than the test statistic. And the way we find that is to calculate the probability that t is less than or equal to negative 4.18. And to do that, we need second vars. The one you want now is number 6, TCDF. Great. So it's going to ask for lower limit, upper limit, and the degrees of freedom. So the lower limit is negative infinity, which we enter as negative second comma 99. The upper is the negative 418. Degrees of freedom is 59. Now, whatever this number is, it's going to be really small. Okay, let's find out how small it is. So this is kind of an interesting result. It's so small that the calculator felt the need to express it in scientific notation. So if you look carefully at the end here, you'll see this E minus 5, which means, yeah, that's what it's trying to tell us, which is actually equal to, yeah. Okay, so remember the rule here. P is less than or equal to alpha means reject the null, accept the alternative. And of course, if P is greater than alpha, we simply do not reject the null. But I think here we can all agree this is less than alpha. Okay. And that means we reject the null, that the mean is at least 3.5, and accept the alternative that it's not. And once again, the two approaches always have to give us the same results. If not, that means you've done something wrong. Okay. All right. So what else do we have here? Number 2. The Coca-Cola Company. So what's going on here? Um, the Coca-Cola bottling company wants to make sure that its 1 liter bottles are filled correctly. Of course, if the bottles are underfilled or overfilled, the company will take corrective action, which means it's a two-tailed test. They're looking for evidence either way, too low, too high. We have to do something about it. So let's write that right here. Now, again, just like before, we want to know about it if the mean is not equal to 1, but we need hard proof of it because this is going to be a very costly procedure if we have to correct the way the soda bottles are filled. So we'll do this if it's necessary, but only if it's absolutely necessary. So because we're looking for evidence that the mean is different than 1, that becomes the alternative hypothesis. And then the null would be that it does in fact equal 1. Alpha is 0.01. Now the sample size is 100. The sample mean is 0.989, which sounds kind of low. And the sample standard deviation is 0.05. So once again, this is a hint that we should use the t distribution. All right, so the test statistic. Now, this is very much like the other problem, except that it's a two-tailed test. - 0.989 minus 1 over 0.05 over the square root of 100. Okay. I've got negative 0.22. Now, that's a very small number. Oh, wait a minute. I think I did something wrong. Oops, hold on one second. That's what I was afraid of. Sorry about that. It's negative 2.2. I made, of course, a typo in the calculator. All right, so let's go look up the critical value, or in this case, there's two of them. All right, and that's because it's a two-tailed test, of course. Also, don't forget, in this case, alpha is zero point 0.01. We usually don't see that. It's usually 0.05, but we have to always read that very carefully because it could be 5%, 10%, or 1%. All right, now, of course, this we have to look up in the calculator. And of course, also, they're both the same number with different signs, so we can look up either one of them. All right, so let's say you decide to look up this one. You would go to second vars for INVT. And again, it'll ask you for two things, which are the area and the degrees of freedom. The area is everything to the left. Degrees of freedom here is 99, n minus 1. Okay, negative 2.63, let's say. Round it off a little bit. All right, so now that, of course, means this lower critical value is negative 2.63. The upper one is positive 2.63. And that defines the boundaries of our rejection region. All right, but our test statistic, as large as it isn't quite large enough to reach into that rejection region. Minus 2.20 is right here. So Coca-Cola breathes a sigh of relief because this means that we do not reject the null. And that means no changes are needed. Now, as far as the p-value approach goes, this is a two-tailed test, so we have to watch it. It's a little trickier. What we're going to look for is this. Not just everything to the left of negative 2.20, but everything to the right of positive 2.20. All right. And that's because it's a two-tailed test. So what we can do is calculate the probability that t is less than negative 2.20 and then double it because both of those tails have the same probability. Right. So we go to our calculator and we have second vars, 6 TCDF, and they need to know for three things: lower limit, upper limit. Oh, that's right. It doesn't actually say the word limit there, but that's what it means. And DF, degrees of freedom. All right, so of course we don't have a negative infinity key. We instead use negative second comma 99, which is replaced in the window by negative, actually it's negative 1 E99. Upper is the negative 2.20, and we have, since the sample size is 100, we have 99 degrees of freedom. And that will be, okay, so it's 0.015, almost exactly. So the p-value is double that. Now keep in mind the alpha was 0.01, not the usual 0.05. And that means do not reject the null. Okay, so there you go. All right, what's next? So an art gallery wishes to know if the average value of its paintings is greater than $100,000. All right, so they're giving you a hint that this is a right-tailed test. Now, why is that? Because if that turns out to be the case, they're going to pay a larger commission to the salespeople. So they're willing to do it, but they have to have hard evidence that it's necessary because the mean is actually above 100,000. So it means that their profits are higher than they realized, and that, the salespeople should share in some of that. Okay. So this is indeed a right-tailed test. Now we've got an alpha of 0.10. We haven't seen that. We don't see that very often. Um, a sample of 12 paintings is taken. Um, Sample mean 101 5,000, 500, what am I saying? And then S, the sample standard deviation is 1892. And again, we're going to use the T distribution. All right, beautiful. Of course, this is the hypothesized mean of 100,000. All right, so let's see what we get. I have approximately 2.75. Yeah, that's right. Very good. Just want to make sure if the last time I didn't make a typo. All right, now the critical value, there's only one this time because it's a right tail test. But don't forget the alpha is 0.10. We don't see that very often, so be careful with it. And then n minus 1 is 11. So we go to second vars, INVT. Okay, and that wants to know area and degrees of freedom. Of course, remember the area means left tail. Degrees of freedom is 11. I'll get 1.363, let's say. Okay. And what do we do with it? Of course, we compare that with a test statistic. But our test statistic was 275, so it's way in the right tail. And of course, that means we reject the null. And accept the alternative that the mean is in fact greater than 100,000. Which is good news for the salespeople because the salespeople will in fact get a larger bonus. All right. And then what about the p-value? So anything greater than that test statistic will represent our p-value, which we then, of course, compare to alpha. Um, Wait, hold on 1 second. So what we're looking for here is the probability that t is greater than or equal to 2.75. All right, here we go. So CDF, which calls for the lower and the upper, everything from 2.75 up to infinity, which of course we write as second comma 99, and degrees of freedom is 11 because the sample size is only 12. All right, and let's see what this gives us. Oh, it's a tiny, tiny little number, 0.0094. Okay, now given that alpha is 0.10, it's clear that the p-value is well below alpha, which means reject the null. And of course, accept the alternative that it's greater than 100,000. All right. And now we have number 4. Oh, not that one. Here we go. All right. So Major League Baseball wishes to determine if the average length of a game is greater than 3 hours. If so, new rules will be proposed. A sample of 120 games is chosen. The sample mean is 3.1 hours, and the sample standard deviation is zero point 0.7. And we're going to test this hypothesis at the 5% level of significance. So it's a right tail test. We're going to change the length of the games, or we're going to change the rules if the length is dragging on past 3 hours. All right, so alpha is 0.05. And let's look at our data again. Let's see, 3.1 is the mean. Oh, wait, sorry. N is 120. X bar is 3.1. And the sample standard deviation is zero point 0.7. All right, here's our test statistic. Oh, by the way, of course, this is the sign to use T. And hold on. Okay. All right, we plug in the numbers. And let's see what we get. 1.56. All right. So the critical value, there's only one. So remember, N is 120 and alpha is 0.05. All right, so it needs to know area and degrees of freedom. Of course, that means we use 0.95 with 119 degrees of freedom. And that brings us to it's approximately 1.66, let's say. Now here we have a bit of a close call because the test statistic is 1.56. It's really close, but it doesn't quite reach the rejection region. And so therefore, we do not reject the null. Even though it's close, it's not good enough. It has to be in the rejection region to reject the null. So therefore, do not reject the null. That is less than or equal to 3. That's it. So we don't have to change the rules. All right, and what about the p-value? Okay, here's our p-value. Anything more extreme than the test statistic. So we look this up as second vars 6 TCDF, lower and upper, and degrees of freedom. And degrees of freedom is 119. All right, that gives us 0.0607. Now, that's only slightly higher than alpha. Alpha is zero point 0.05, but still it's higher than alpha. So once again, we do not reject the null that the mean is less than or equal to 3. All right, now I think the next question is actually a little bit different. It's about proportions. Okay, so they're not all the same like this one. Um, what is number 5 all about? Ah, here we go. Proportions. So Starbucks wants to determine if the proportion of its customers who drink decaf is more than 0.30. All right, so already we know it's a right tail test. If this is the case, it will increase the amount of decaf that it produces. Of course, they're worried about running out. You don't want to run out of the product. So, the thing about decaf is that all coffee has caffeine in it. Decaf has been treated probably with water filters to become decaf. Okay, it's not like it's grown on a separate tree or anything. So anyway, they have to plan ahead to make sure they have enough decaf. Oh, that's right, the P. So just a quick reminder that the book's notation is this. P for population proportion, P bar for sample proportion. The hypothesized proportion here is written as P0. All right, just to make sure we don't forget how that works here. All right, so anyway, we pick a sample of 120 customers. Oh, before we do that, the level of significance is 5%. So we pick 120 customers, 44 drink decaf. So P bar, the sample proportion, is the ratio of X to N, which is about It's about, let's say, 0.367. That's close enough. All right. So now here's a good question. What is the test statistic here? Oops, sorry, that's wrong. It's Z, not P, Z. So you may remember this one was constructed in two stages in the slides. It doesn't have to be done this way though. But just as a reminder, it's P minus P zero, the hypothesized value, over this term. Oh, and that's formally known as the standard error of P bar. And that in turn equals, okay. So if you want to combine them, then you can do it like this. All right, so the hypothesized proportion is 30%, and the P, the sample proportion that we just calculated is 0.367. And oh, and of course, N is 120. Let me just double check. Yep, 120. All right, so we'll plug in the numbers. Oh my God. Now, I think the reason why they wrote the test statistic this way is I think they're encouraging you to calculate the denominator first before you do this because it is kind of a mess. So let's do that right now. We'll start by simplifying a little bit. Um, it's like 0.041833. All right, so that's going to give us approximately 1.6. It's almost exactly 1.6. 1.601, let's say. All right, now the alpha is 0.05. This is a right tail test. So the critical value is, so quick reminder, always use the standard normal distribution with proportions. Never T. T does not apply here. It's got to be Z. All right, so let's check this out. All right, so we'll go to the calculator. And this time we'll look for number 3, INV norm, and it will want to know area, of course. And of course, it also means left tail area. And then, of course, the mean and standard deviation, but those are understood to be 0 and 1 because this is the standard normal. Okay, so if you plug that in, you'll have, whoops, 0.95. The rest is by default already there, 1.645, right? That's a number you've seen before. It's starting to get very familiar. All right. Anything, of course, above that will cause us to reject the null. And if you recall, our test statistic was 1.601. Ooh, another close call. Look at that. All right, so that means clearly we do not reject the null. And that means that the proportion of decaf drinkers is 30% or less. Okay. And that means no changes have to be made. And that's again, that's good news for Starbucks. They did not want to change their procedures. All right. Now, of course, we now want to check out the p-value. It's very straightforward. Anything greater than 1.601 represents the p-value. Because that's a test statistic. And we find that by calculating the probability that Z is greater than or equal to 1.601. on the calculator. All right. So therefore, we need to know lower limit, upper, mu and sigma, everything from 1.601 up to infinity is what we're looking for. And that will be 0.055, let's say. Now the alpha is 0.05, so we have another close call here. But anyway, you look at it, the p-value is greater than alpha, which means do not reject. And that's it. All right, so that was the first part of this. There's another part. Let's see what that's all about. Let's see, part two. Oh, I guess I forgot to open it up. Um, all right, let's go back to Blackboard and look for it. There it is. Oops, wrong one, sorry. There we go. All right. Looks like this one has more proportions. That's fine. We could use the practice. Oh my God, I got so much stuff open. All right, here we go. All right, so I should have probably labeled the first part. I don't think I did. All right, now we're ready. Let me save this real fast. You never know what's going to happen. Okay, what is this one all about? So these will, of course, all be very similar to the one we just did, but that's okay. Now, I don't know why I put a 5 in there. All right, what is it telling us? In previous years, the proportion of students passing the CPA exam was 44%. In the past few years, new study materials have been made available in order to increase the proportion of students who pass the exam. Last year, we had a sample of 250 students taking the exam, of which 130 passed. Does this indicate that the new study materials were successful, meaning that the proportion has gone up? All right. So, in other words, it's kind of a roundabout way of saying, let's test the hypothesis that the new proportion is more than 44%. Now, we need hard evidence of this before we start going around making claims. So, we'll set it up as a right tail test. Right? If we reject the null, it means that the new methodology for studying for this test um, is an improvement over the old one. Okay, beautiful. All right, so alpha is 0.05. And because this is a proportion problem, we don't have to worry about whether to use T or Z. It's always Z. Um, we had a sample of 250 students, 130 passed. Um, no, sorry, that's 52, which sounds quite a bit higher than 0.44, doesn't it? But you never know. That's why we need to do these tests. Okay, great. Oh, yeah, and N is up here somewhere. It's 250. All right, well, let's plug in the numbers. First, we might as well calculate this part first. $250. All right. 0.0314, let's say. It's about 2.55. All right. And then, of course, now we need a critical value to compare it with. And once again, it's a right tail test. That's right. So we're looking for, now, let me just double check that. Yes, alpha is 0.05. Now, we just looked that up, as you recall. There it is. We've already seen this in this example here. We don't necessarily have to go back to the calculator. It is actually 1.645. Or you can go back to the calculator if you forget. But our test statistic is way out in the right tail, 2.55. It's really not even close. So, of course, that means we reject the null. That the proportion is less than or equal to 0.44. Accept the alternative that it is greater than 0.44. And that's excellent news because it means the new method is better than the old method. Uh, Hold on. All right, and now we can go ahead and use our p-value. Hold on. So anything above that test statistic is the p-value. And we find that by calculating the probability that z is greater than or equal to 2.55. So we go to second vars. Normal CDF. And what do we get? It's very small. I figured it would be 0.0054, let's say. And once again, alpha is 0.05 in this case. Where did I write it? Yeah, there it is. Okay, good. All right. So of course that means that the p-value, less than or equal to alpha. So we reject the null. That the proportion is less than or equal to 0.44, except the alternative that it is greater. Okay, very good. So I think there's only two more of these, but they're very similar. But all right, let's keep going. All right, just in case there's a twist in there somewhere. I don't think so, but let's see. So the commissioner of Major League Baseball is interested in determining if the proportion of switch hitters in the major leagues has declined since the 80s when it was 8%. All right, so a left-tailed test. We're looking for evidence that the proportion is less than 0.08. Alpha is 0.05, and we know that the sample is 40. Three are switch hitters. And 3 over 40 is about 0.075. All right, so the test statistic, as before, well, let's start writing it like this. Um, Again, it's probably easier to calculate it this way by breaking it up into two parts. All right, so remember, P bar was sorry, the hypothesized value is 0.08. One minus that is 0.92, and N is 40. All right, so we're going to get about 0.0429. That's close enough. Yeah, so I just want to double check something. I just realized I think I've been leaving off these little P bars here. Let me just double check. Um, you know why? Because every book is different. Some of them use it and some, here it is. Only the reason why is because you can tell the difference between the sample proportion and the hypothesized. Let me just fix that real fast. Yeah, I guess, whoops. Right, because that's the book, the population proportion is plain P, which we don't know. Okay, we have the hypothesized and we have the sample. Oh yeah, see, I have it here, but then I left it off here. Okay, it should be okay now. Sorry about that, because the book we used before this didn't use the bar, so I just forgot about it. Sorry about that. The P bar is for the sample proportion. It doesn't affect the results, but it's just it's we want to be consistent. The P bar means the sample proportion. Okay, plain P is the population version. All right, we're good now. Yeah, see now here is plain P because that's the it's the population version that we cannot observe. Okay. All right, I think we're solid here. All right, now we can do this properly. All right, here we go. Negative 0.1166, let's say. And the critical value, again, this is a left-hand test. All right. And our alpha is 0.05. Yep. All right, so let's look it up. Um, we're going to use second of var's INV norm. All right, area to the left is 0.05. And these are 0 and 1 because it's the standard normal distribution. And we get negative 1.645. Okay, but the test statistic was only, wow, negative 0.1166. It's not even close. All right, so it's clearly not in the rejection region. So we do not reject the null, that the proportion is at least 8%. So it basically means that the proportion of switch hitters has not changed. All right. And the p-value will be anything more extreme than the test statistic in that left tail. All right, so we go to the calculator again. All right, so oh, hold on. Upper is the negative 0.1166. And this leaves us with yeah, it's pretty high, 0.4536, which is clearly well above alpha. Alpha was 0.05. Yeah. All right. And it's, of course, it's the same conclusion. It has to be. All right. So there's one more. Um, oops, that's 10. There we go. So university, which is to determine the proportion of students studying business administration, has changed in the last 20 years. Previously, the proportion was 24%. Now, if you notice this time, they just want to know if it's different, not greater, not less, different. And that makes it a two-tailed test. All right, alpha is 0.05. We have a sample of 90 students. 25 are majoring in business administration. And that sample proportion is it's about zero point 0.2, let's say 78. All right. All right, let's calculate the standard error first. All right, here we go. It's about 0.045. So what does that give us? P bar is 0.278 minus 0.24 over 0.045. Ah, so it's a pretty small number, 0.844. Oops. All right, so anyway, the critical value, or values, I should say, it's a two-tailed test, so it's plus and minus z alpha over 2. Alpha is zero point zero 0.05. All right, let's take a look. All right, so we can find these. We can take it from there if you want. Um, all right, what does that give us? Okay, negative 1.645. And that means that up here, this one is negative, and this one is positive. But the test statistic is only 0.844. That means we do, of course, do not reject the null. So the proportion studying business has not changed. All right. And of course, we still need a p-value. And this is a two-tailed test. What we have to do is this. We need both tails. All right. So we're going to get 2 times We'll double the left tail. All right, so we have lower, upper, mu and sigma as always. Whoops. Now these are still 0 and 1 because this is the standard normal. Oh, I'm sorry. I'm looking at the wrong thing. Um, that's the mu and sigma. All right, so we're looking at this one, negative point. This will be anything from negative infinity up to negative 0.844. All right, let's see what that equals. It's almost exactly zero point 0.2. All right, so that's in both tails because of the symmetry of the distribution. And so, of course, that adds up to about 0.40. That's our p-value. Therefore, the p-value exceeds alpha. Do not reject the null. Okay. All right. So that's that for the chapter 9 problems. So here's what I think we should do. There's two chapter 10 problems and a sample midterm. And so maybe we could save those for Monday. And then Tuesday, we can go over or start chapter 14, I think. Okay. So, yeah, this is a lot of work, but it's good practice. So we still have the two parts to the chapter 10 problems, and the sample midterm is of course includes both chapters. So that's probably going to take a while. So why don't we save those until Monday? And if we finish them on Monday, we may not, but it'll be very close. We can start or finish those on Tuesday and then start chapter 14. Okay. So I'll see you then.